All right, so we're jumping into chapter 4. We're talking about 4.1, and we're going to talk about radians and degrees. And when Miss Shannon was here, she would talk about when her students got into trigonometry that they were in the deep water. So we're just starting to get into the deep water, but today we're just going to kind of dip our toes in. So let's start with, we're going way back to geometry. An angle. How do we define an angle? What makes up an angle? What's it? What do we put together to make angles? Two lines. Is it lines which do they have to intersect? And so if we were being more specific, if we were just talk, so our lines go forever in both directions. So if we wanted our angle just to go one direction, what would we put together to make rays? There we go. So we want intersecting rays, I guess would be a good way to put it. And part of what we're going to do today is there's a lot of terminology, a lot of vocabulary that we're going to use throughout the entire, for this entire unit and really for the rest of the semester. So we need to know what we're talking about when we're referring to all these things. So let's draw a picture of an angle. I'm going to put our angle on a coordinate axis. We always want to be able to measure these things. I'm going to draw two rays that start at the origin. So there's one, and we'll put the other one right along the x-axis. So there are my two rays. There's my angle. You remember what we call this point here where they intersect? The vertex. We're going to call the side first. When we put an angle on the coordinate plane with its vertex here at the origin and one side along the x-axis, we call this standard position for an angle. So you'll be asked a lot about an angle in standard position. This is what it means. One side along the x-axis. We call the side that's on the x-axis the initial side. And the other side is the terminal side. And we measure an angle by how far the terminal side rotates from the initial side. So that's going to be our measure. And we love to use in trigonometry theta for our angles. So we measure an angle by how far it rotates from one to the other. When we rotate counterclockwise, that's the positive direction. So a positive angle is rotating counterclockwise. And a negative direction is rotating clockwise. I want to make that an arc. So when we rotate positive, when we rotate counterclockwise, we're going in the positive direction, and clockwise, we're going in the negative direction. So there's our a picture basically of what we're going to be talking about for a good part of the unit. Is this angle and how things happen with this angle. If we're talking about what quadrant, you might be asked what quadrant the angle lies in. That's talking about the terminal side. What quadrant means where is the terminal side? So the quadrant of an angle refers to its terminal side. So this would be, we would call this a first quadrant angle because the terminal side is in the first quadrant. So over here would be the second quadrant, down here third quadrant, over here fourth quadrant. So when we're talking about the quadrants, we're talking about where is the terminal side. We can start here on the x-axis and rotate here, but I could rotate to here and go around another full rotation, and my terminal side would be in the same place. So if I went to here and then went around another full rotation, I would be rotating further, but my terminal side would be in the same place. We call those kinds of angles coterminal. Coterminal just means that their terminal sides are in the same place. And both of our angles, we're talking about angles in standard position here. So if we're starting in standard position, coterminal angles have their terminal sides in the same place. So that's what we mean by a coterminal angle. Let's go around another full rotation. And we can go in the positive direction or the negative direction to get a coterminal angle. All right, so there's a lot of vocabulary, a lot of ideas, basic ideas, just in this little drawing, and the vocabulary that we're talking about comes up very frequently when we're talking about trigonometry. This idea of coterminal and the quadrants comes up a lot. So it's really, what we're doing today is getting an introduction to all of this. So mostly what we've done with trigonometry in the past, the vast majority, maybe not all, but we've talked about angles in degrees. In trigonometry, we're going to use a different unit that's a little more convenient, that helps us do certain kinds of things. So that's what we're going to talk about next, radians. And I want to start by talking about what radians are. So I'm going to draw another angle, and in standard position, and we'll talk about radians. So here's my angle, standard position. There's the initial and the terminal side, and we've rotated through this angle theta. What we're interested in with radians is this arc length. So we're thinking of that angle rotating through a circle. So this is our arc length. How long is that arc? When we're the normal symbol for arc length that you'll see often is we use the symbol S. So we're going to say S equals arc length. In radian measure, our angle is the arc length divided by the radius. So the radius is the length of our ray. We're talking about if we're thinking about this as a circle, then in radian measure, we're saying that our angle is the arc length divided by the radius. 1 radian we define 1 radian as the angle where the arc length equals the radius. So we define 1 radian as the angle that we have to rotate our ray through so that the arc length is the same as the radius of our circle. That's how we define a radian. So 2 radians would be the angle so that our arc length along the circle is 2 times our radius. 3 radians would be the angle where the arc length is 3 times the radius. So this is how we define a radian. Well, what do we call the arc length all the way around the circle? The circumference, right? So in a circle, for a full circle, and what's our formula for the circumference of a circle? And I'm going to call it arc length instead of circumference. What is it? 2 pi r. Well, if I rearrange this formula, this tells me that S equals r times theta, multiply both sides times r. So what does this tell me? That the radian measure of a full circle is? What's my angle? 2 pi. There are 2 pi radians in a full circle. And this is one reason why radians are convenient to use when we're talking about trigonometry, because it relates the angle to the properties of a circle. And we'll get more into that later as we go more into trigonometry. So we have 2 pi radians in a full circle. Our angle, the angle that we've rotated that ray through, is 2 pi radians. 2 pi is about how much? 6, yeah, a little over 6. So there are just a little over 6 radians in a full circle. So that's how we define a radian. And the reason that we're using radians is it relates this angle to circles. And that's another part of what we do in trigonometry. All right, so let's talk about some common angles in radians. So a full circle is 360 degrees. So we decided that was 2 pi, and our symbol that we use for rad is rad. And often we don't, and we'll talk about, let's go through this and then I'll talk about why we don't use symbols for radians. So if 360 degrees is 2 pi radians, what would 90 degrees be? We're going to look at some common angles. Pi over 2, because, and how did you get that? And divide by 4. 90 degrees is a fourth of the circle. Pi over 2. How about 180 degrees? Pi radians. 270. 3 pi over 2. And a lot of times you hear people talk about 3 pi halves. Let's talk about some other common angles. 45 degrees. Pi over 4. And our special, we'll talk about our special right triangles. How about 60 degrees? Pi thirds. And 30 degrees. pi over 6. So those are some very common angles that show up very frequently in trigonometry in degrees and radians. We will work more with these. We'll eventually, hopefully, these you won't even have to think about these conversions. We'll know all of these, and we'll relate them to some other things. All right, so now we know what a radian is. Radian is this angle where the arc length equals a radius, and it allows us to work with this quantity of 2 pi. So questions so far? Let's talk about a little bit more vocabulary then. And then we'll talk about how we convert. What do we mean when we're talking about an acute angle? Less than 90 degrees. So in radians, less than pi halves. So I'm going to say between 0 and pi over 2. So an acute angle between 0 and pi over 2, and obtuse. That's going to be an obtuse angle in radians. Three 360 in pi? There we go. Well, 180 is pi, right? Between pi over 2 and pi. Between 90 and 180 degrees is an acute or an obtuse angle. So we're going to be between pi over 2 and pi. How about complementary angles? What do we mean when we're talking about complementary angles? So I hear two numbers. I've heard 90 and 180.
90. 90.
Anybody sure? 100% certain? 90? Maybe 90? Who thinks 90? Ah, a nice little mnemonic there. Complementary means they add up to 90 degrees. So in radians, they would add to 90, or in radians, pi over 2. And when we're talking about complementary angles, we're talking about positive angles. All right. How about supplementary? Add to pi. Radians. So if we're given an angle and we want to find its complement, what do we do?
Minus pi.
Subtract pi over 2. And find the supplement, subtract pi. And remember, we're looking for positive angles. We're talking about complements and supplements, we're talking about positive angles. All right, so nothing too complicated here, nothing too difficult, just remembering some vocabulary. Now let's go back to the idea of a coterminal angle. We said a coterminal angle was an angle in standard position, but we could go around a full rotation and have the terminal side be in the same place. So if we're given an angle, how would we find a coterminal angle? We're going around the full rotation. Add 2 pi. This gives us a positive coterminal angle. We can also find a negative coterminal angle by doing what? Subtract. We'll go the other direction. So we just rotate the other direction. So the way you'll be asked these questions a lot is they'll say find one positive and one negative coterminal angle with such and such an angle. So all they're asking you to do is add a full rotation and subtract a full rotation. That's all the question is asking us. Okay, we good with the vocabulary so far? All right, so that's mostly what this first section is vocabulary. Remembering what vocabulary is and introducing this idea of a radian. All right, the last thing we need to talk about is how we switch back and forth. Sometimes we have our angles in degrees and we want them in radians, or the other way around, and we want to know how to deal with that. All right, so 2 pi radians is how many degrees? So 1 radian would be how many degrees? How would we figure that out? We just divide both sides by 2 pi, and we get 1 radian is 180, and I'm going to write it this way, 180 over pi degrees. So there's our conversion from radians to degrees. So going the other way, 1 degree would equal how many radians? Pi over 180. So there are conversions from radians to degrees. This is how we're going to convert. So if we have, we'll do a couple of easy examples here. 120 degrees. Now you'll be asked these questions in a couple of different ways usually. Some will say convert without using a calculator. So without using a calculator, what they mean is write your conversion and then just reduce the fractions. So we're going to do this first one without plugging into our calculator. We could plug it into our calculator, but this is nice. So 120 times, and we want to convert to radians. We're going to multiply by pi over 180. And we're going to reduce that fraction. So what is this fraction reduced to? 2 pi over 3. So when we don't use our calculator, or sometimes it'll ask you for an exact answer. So this would be our exact answer, 2 pi over 3. Let's go the other way. We want 5 pi over 6. And we're going to convert that to degrees. So we're going to multiply 5 pi over 6 times 180 over pi. And what does that simplify to? 150, very nice. 150 degrees. So we're just reducing the fraction. We cancel out the pi's, divide by 6, multiply by 5, simplifying our fractions. This is 150 degrees. So if the question asks you do the conversion without using your calculator, they're just saying do this and simplify your fractions. And sometimes they'll ask you to express your answer to 3 decimal places. That means plug it in your calculator and multiply everything out. Questions on that? Should be a nice, gentle introduction today. Monday we'll talk about arc length and angular velocity, but still just talking about angles and arc length and the radius of the circle. I want to show you how to do one thing on your calculator. sometimes you will see in navigation, sometimes in surveying, you'll see angles written in degree, minute, second notation. So for example, if I had 245 degrees, 10 minutes, 34 seconds. So sometimes, and this is a little older terminology, but you'll still see it, like I said, in navigation and surveying. What this means, and our calculator is going to do this for us, but 1 minute is 1/60th of a degree. And 1 second equals 1/3600th of a degree. Just like a minute is a 60th of an hour and a second is a 3600th of an hour. So it's kind of like thinking of degrees as hours and subdividing the degrees that way. But thankfully, you can do the conversions this way. It's a little tedious, but it's possible. But our calculator does this for us. I want to show you how to do it with your calculator. So let me pull that up. Once that gets fired up, we will calculator here. All right, so on our calculator, to do this conversion, I'm going to enter in 245, and then I'm going to we have an angle menu here above the apps, so angle, and that first one is degrees. So I hit enter. So there's my 245 degrees. I have 10 minutes. I'm going to do 10. Go back to the angle menu, and the second one is my minutes. So there's 245 degrees, 10 minutes. The seconds, 34. The seconds, I don't know why they put them where they did, but it's right here above the plus sign. Then that's the alpha key. You do the alpha and that. And there's my angle in degree, minute, second. To convert it to decimal, I just hit enter. Boom. And there we go. Yeah. What's that? Sure. So I did 245, and I'm going to go to the angle menu, which is the one above the apps. So hit second, and the first one is angle, so I just hit enter. There's my 245 degrees. Then I hit 10. Go back to the angle menu. No, yeah, it's the shifted one, the second. Minutes. Second is the alpha on the plus key. And I hit enter. And there's my decimal degrees. And the calculator will also go back the other direction. So if I had 185.765 degrees, and I wanted to convert it to degrees, minutes, seconds, I would go to the angle menu, and this fourth option converts it to degree, minute, seconds. And hit enter, and there we go. 185 degrees, 45 minutes, 54 seconds. So just so you know how to deal with those angles when you see them, there'll be a couple of your homework problems that ask you to do that conversions. And we might see some navigation problems that deal with angles in that way, and then we can convert them. Questions? All right. Homework, nice easy day today. And these should be quick, easy problems. Sketching angles, converting, talking about where your terminal side is.